EVPN and VxLAN, two huge protocols working together for data center networks and campus fabric environments. And in this video, what we are going to go through is how to validate that EVPN is routing and exchanging MAC addresses correctly. Hey everybody, and welcome back. I'm David Townsend from the Net Academy, where we are learning networks together. And on this video, what I'm going to be going through is how to validate EVPN or Ethernet Virtual Private Network in terms of is it up and running and exchanging all of those route types, like route type 1, 2, 3, 4, etc., in a data center or even maybe in a campus fabric network. Now, as we've gone through in previous videos, EVPN is a huge protocol. And if you haven't seen one of those videos, just please check out this link. It covers the basic concepts that you need to know before going any further. So please start there before watching anything else. But we are here to go through how can we validate that all of those tables for EVPN, for maybe the underlay and the overlay, are populated correctly. And what does all of that information, that rich information, actually mean in all of those route tables? Now, honestly, this might not be the hottest topic. It might not be the sexiest topic. And I can agree with that because I like to configure things and configure the underlay and the overlay. And I just get a buzz from getting that technology to work, for those protocols to work. But here's the catch. When it doesn't work, you need to know what show commands to actually use to go into all those different tables to interpret what's going on, what's going wrong. Now, we're not going to do any troubleshooting here. This is more of a video to validate that EVPN is up and running and that the information there, what does that information actually mean? And also, there are a huge number of variables for these various show commands. As I said, EVPN is a huge protocol. There are a lot of variations for any given show command. So obviously I'm not going to be able to go through them all, but I just want to show you what my top picks are as such for those show commands when it comes to validating that EVPN is exchanging those route types and those MAC addresses correctly, and how to interpret that in those various routing tables. So no more said, let's get going straight into the lab. And here is the lab that we're going to be using to validate EVPN. Now, this lab, this topology, these routers or multi-layer switches, they've already been configured. I've already configured EVPN. If you want to see what I did in terms of configuring EVPN and VxLAN, then please check out this link. It's the last video I've done in this EVPN VxLAN series. It's all described there on how to configure EVPN and VxLAN in 8 steps. I'm not going to go through that again because the purpose of this video is to show my top picks as such, i.e. the various powerful show commands to validate EVPN is functioning correctly. But just as a quick recap, we've of course got this lab here, and this lab is configured to have an ERB or Edge Routing and Bridging model. What does that actually mean? It means that those IRB interfaces, those integrated and routing bridging interfaces, are on the leaf devices, so leaf 1, leaf 2 and leaf 3. And if you recall the previous videos I've done regarding this series, when I'm talking about IRB, or when we refer to IRB, whether it be an ERB or CRB model, it's of course referring to those Anycast gateways. So an Anycast gateway will have a virtual IP address, and that's very interesting because whether it be ERB or CRB, that virtual IP is the same IP address, this Anycast IP address that is shared on, in this case, leaf 1, leaf 2 and leaf 3. If it was a CRB model, then spine 1 and spine 2 would have that same virtual IP address, that Anycast IP address. But this is using an ERB model. And also for your information, the whole network here is between the leaves and spines is layer 3. And referring back to the previous video I did, we built the underlay using OSPF, so open shortest path first. I had a question as to why you're using OSPF when Juniper recommends eBGP as the underlay. It's simply because for a lab this big, you don't need something as powerful as eBGP. Obviously, this is just a learning process, and OSPF is a protocol that generally I like. It's open standard, it's been around for a long time, and it just works. But we built the underlay using OSPF, and then when that underlay was built, we then built iBGP on top of that underlay, and within that iBGP we configured route reflectors on spine 1 and on spine 2, and that was a big benefit because any host devices such as host 4 in this example, when it ARPed into its gateway, into the Anycast gateway on leaf 4, leaf 4, because it's part of that EVI, if you don't know that, again refer to the part 1 I've done in this series. But what leaf 3 and any leaf would do, because it's an ERB model, is it would advertise over to leaf 2, over to leaf 1, via spine 1 and spine 2, host 4's MAC address and maybe its IP address. And coming back to the route reflectors, spine 1 and spine 2, when they receive the routes from leaf 4, they just automatically advertise that down to leaf 1, to leaf 2. They just reflect it. And as such, there's not a lot of configuration that we actually needed to do. Yes, absolutely, all of this needed to be in the same autonomous system number, or ASM, but the route reflectors just gave that flexibility and just reflect those routes on that overlay. Also for the OSPF, one thing that you do always have to remember is that we built and we advertised the loopback 0 addressing .0 or whatever that unit is into the underlay, and that's how we built the iBGP. That overlay, whether it be iBGP or eBGP, it is built using the loopback addressing. So you always have to advertise that loopback address into that underlay. But we've built the network, as you could see here. All of this is built on layer 3. And then we actually started to build the EVPN network. We started to say that the encapsulation was VxLAN. And that's important because we're saying we've got the underlay, we've got the overlay, and now we want to advertise all of these hosts' MAC addresses and maybe their IP addresses using EVPN. But we want to encapsulate all of that different EVPN route types into this tunneling, this data plane technology that is VxLAN. So that is a very quick review into this lab. But before I go any further, what you can also see is that host 1 is in VLAN 10, host 2 is in VLAN 10, host 3 is in VLAN 20, and host 4 is in VLAN 20. If you want to think of it as VLAN blue, VLAN green, up to you. I've just gone technically, I've done things as you would do on a actual COI and done the VLAN 10 instead of the name of the VLAN. But the blue VLANs are configured to be in the virtual network instance, that VNI 5010. And the green, or VLAN 20, are configured to be in that VNI of 5020. And that's important because these are just virtual networks at the end of the day. If host 1 wanted to communicate to either host 3 or host 4, then it's got to have that gateway. It's got to have that layer 3 gateway. Where is that gateway? Well, again, remember that is on the leaf devices because we configured those, or this network, to be an ERB. So if host 1 wanted to communicate to host 4, it would send the packets up to, whatever those packets are, up to leaf 1, where the IRB would then route the packets from 5010 over to 5020, from VNI 5010 over to 5020, before reflecting, well, sending the packets over the network either via spine 1 or spine 2 onto the destination. So that's just a quick recap, but again, the process here is to validate, and I just wanted to give a recap so you can understand that the setup before we go into the show commands. If I didn't do this, it wouldn't make any sense in terms of what you're seeing on the show commands. And really, all the show commands I'm going to be doing are from Leaf 1's perspective. I'm not going to go into the spine devices, spine 1 or spine 2, because they're just route reflectors. They're not really participating in the EVI. They're not really participating in EVPN routing. But all those show commands are going to be done on Leaf 1. And coming back to the point, this is important because we want to do show commands on the underlay. As I said, we built the underlay using OSPF, so we need to do various show commands to check, is the underlay built? Are those neighbors up or established? Are they connected? Are they exchanging for OSPF those DBDs, those database descriptions, those different link state advertisements to build that database? So we need to do various show commands to validate, is the underlay built? We also need to do various show commands to validate, is the overlay, that IPGP peering, actually built? Have we got established peering to those two spines, spine 1 and spine 2, from Leaf 1's perspective? If not, then EVPN's obviously not going to work. And once we've done this, we can then start running the various show commands to validate the EVPN, the Ethernet Virtual Private Network. Now, I'm going to show you two show commands that is going to validate that the instance, that EVI, that EVPN virtual instance, is functioning correctly, and also going to validate the database itself. So two different show commands which are going to give very different outputs. One's going to validate the instance and the other is going to validate the database. Just like OSPF, where OSPF has got a database of learned and received link state advertisements, EVPN has got a database of all received and learned remote MAC addresses and ESIs and designated forwarders, etc. So we're going to go through the show commands to validate EVPN for the instance and the database, and of course a little bit more. I also want to compare this to what you see when you go into the ARP table. The ARP, Address Resolution Protocol, is where a switch, Leaf 1 in this case, will store the learned MAC addresses and IP addresses. So it's very interesting when you look at the ARP table to see those MAC addresses, both local and remote, and how that compares to that EVPN database. So again, that's just a very nice little command that you can use to see those MAC addresses. And don't forget, EVPN is all about MAC addresses. That route type 2 will advertise a host's MAC address and even a MAC address of that gateway, that virtual gateway, to all remote Leaf devices. If you don't know the full benefits of EVPN, just check out this link. It's all described there. But really what we're doing here is that we are verifying, are the MAC addresses actually being learned? MAC being the point here of EVPN. The bread and butter of EVPN is to advertise MAC addresses. So whether it be via the EVPN database or via ARP, we are validating that those MAC addresses are being learned and advertised and received locally and remotely, respectively. But also I want to validate the VxLAN. I want to validate that those VTEP tunnels, those VxLAN tunnel endpoints, encapsulation, de-encapsulation points, are configured and have been built automatically. And what are those VTEP tunnels? And what addresses and VNIs are being advertised over or to those remote VTEP tunnels? What are the show commands to actually validate VxLAN? And of course, right at the end, we're going to go into the route tables as well. There's quite a few route tables, but I want to show you via the show commands the different route tables that you need to be aware of when it comes to, guess what, EVPN. But throughout all of this, we want to validate, do we have our entries in our various tables, whether it be the ARP table or the EVPN database table or a specific routing table. We want to validate, are the entries actually there? Do we also have inter VNI connectivity? This is important because, as I said, we've got two different VNIs. We've got VNI 5010 here, and we've got VNI 5020 here. So what happens if host 1 wants to communicate to either host 3 or host 4? It's got to go through its gateway. It's got to go via the IRB. But if that's not been configured with VNI 5020 and it's not being configured to have that encapsulation in EVPN for that VNI, etc., and even that VLAN, then it's not going to work. But so we want to verify, do we have inter-VNI connectivity? And so here we go. I've logged into the command line interface on Leaf 1. Again, all the shell commands I'm going to be doing is or will only be on the Leaf 1. So first let's log into the command line interface, and I don't need to go to the configure mode because again we're just doing shell commands, we're doing validation. So remember, the first thing I want to validate is OSPF, is that underlay. We built the underlay using OSPF, and I just want to validate, do we have connectivity, and maybe do we have those loopback 0 addresses actually being received and advertised. Now those loopback 0 addresses, they're actually the same as the router ID. So if you look at spine 1, spine 1's router ID is 1.1.1.1, and thus the loopback 0 address will be the same for spine 1. The spine 2 will have its router ID the same as its loopback 0, and the same for leaf 1, leaf 2, leaf 3. So you can see the information on there. But if I just do quickly, this just validate the underlay itself. So I'm just going to do show OSPF neighbor. Now at this point, this is great. I've only got 2 adjacencies. And that is correct because from leaf 1's perspective, for the underlay, it doesn't need to build adjacency to leaf 2 and leaf 3. No, it only needs to build the adjacency up to spine 1 and across to spine 2. And leaf 2 would do the same to spine 1 and spine 2. Leaf 3 would do the same, building the connectivity, that underlay to spine 1 and spine 2. And they would then advertise their loopback 0 addressing into the underlay. And that's why you're only seeing 2 adjacencies, 2 neighbors being built here. So the addressing's not shown on here, but you can actually see the GigE 001 and GigE 002 interface. So GigE 001 to spine 1 and GigE 002 to spine 2 respectively. And both of these are up. Both of these are running full. And here's the ID 1.1.1.1 for spine 1 and 1.1.1.2 for spine 2. We've really just confirmed there that the underlay is working, but let's check that database. So first let's actually just check, am I advertising my loopback address? So if I do show configuration protocols OSPF, then you can actually see for leaf 1 we are advertising our loopback 0 address. And if I wanted to see what is the IP address of that loopback 0.0 address, then I could do this command here. Now you could see the address is the 1.1.1.3/32, and that is the same as show configuration routing options. It is the same as the router ID. But that's from leaf 1. How can we confirm that we are receiving leaf 2's and leaf 3's loopback 0 address via the underlay? Well, to do that, if I just do show OSPF database, you can see the database that contains all of those learned LSAs. And it's one area. It's all in area 0, by the way. So we've got our router LSAs, we've got our network LSAs, our type 1 LSA and type 2 LSA respectively. And you can actually see the ID here, but this is just from the router ID. That's not actually the loopback 0. Yes, we want to see these same values, the 1.1.1.3 or .4 or .5. But again, these are just the IDs. That's from the advertising router from leaf 2, leaf 3, leaf, yeah, that's it. I'm forgetting the numbers there. But we need to confirm, are those loopback 0 addresses actually being advertised? How can you do that? Well, let's just do show OSPF database, and I want to look at the router LSA, the type 1 LSA, with or coming from a particular router ID. So I want to look at the router LSA that's coming from, let's do from leaf 2. So that is 1.1.1.4. And let's do detail. And here you can actually see all the information that's contained in that router LSA. So we've got this network here and we've got this network here. If you're wondering what they are, those are actually these interfaces here. It's just not shown. But what we really want to look at is right here, the 1.1.1.4 with this particular subnet mask. Now that is a /32 because it's 255.255.255.255. that is the /32. That is that loopback 0 address that is being advertised from leaf 2 under or through the underlay over to leaf 1. We could actually do the same, but for leaf 3. So I'm going to do the same command, but now I'm going to have the LSA ID of 1.1.1.5, which is leaf 3's router ID. And I want to see the detail of that. And here immediately you can now see here is that 1.1.1.5 with this subnet mask that is again a /32. Note as well it's a stub, so there's nothing connected to that, and that is because this is the loopback 0 address. So right there and there we have confirmed that leaf 1, I've done host 1 then, but we have confirmed that leaf 1 has received the loopback 0 address for leaf 2 and for leaf 3. I also know it's there for spine 1 and spine 2, but really the underlay is there, it's built, the adjacencies are connected, and we have that loopback 0 advertisements being sent and received. But now we need to actually confirm the overlay. We need to confirm the IBGP peer. So let me just get a bit of space here. How can you confirm that? Very easy command, just initially show BGP summary. And what you can now see is we have got our two neighbor adjacencies built to spine 1 with this route ID, which is the same as this route ID up here. And we've also got this adjacency to this route ID, which is spine 2's router ID. And you can also see the amount of packets that are being received on the ingress and the amount of packets that are being advertised and sent on the egress. Are there any in the queues? That's obviously good news that that's 0. Have there been any flags? 0. But really here, note established. So that is by far the BGP adjacency state you want to get to. You don't want it to be an idle. You don't want it to be an open confirm or whatever the different states are for BGP. You want to get to this established state. I think open confirm is actually for OSPF, but we want to get to this established state, which actually we have done. And also note here, just immediately, and I don't want to go too far ahead, but note we've got these different BGP EVPN tables, which in itself does show that EVPN is working. And note that the values here, the 30, 30, 30, 0, is referencing these. So the active 30, the received 30, the accepted 0, and the damped being 0. So what does that actually mean? It means that the BGP has built the overlay. We've got adjacency because we could see that they are established. But we can also see we have sent from each spine, which are acting as, again, route reflectors, we have actively sent 30 packets or 0 packets to spine 2. We have received 30 packets from spine 1, 30 packets from spine 2. We have accepted 30 packets from spine 1 and 30 packets from spine 2. And 0 packets are being damped on spine 1 and spine 2. So that is very, very good news. So just in that one command there, show BGP summary is how you can confirm have you got that adjacency actually built. And then you can actually see that those BGP tables are automatically built and are automatically starting to get populated. We'll go into those different routing tables later in this video. So now let's actually start to confirm, do we have EVPN working? You can pretty much see already, as I just described, it is working. But of course, let's go through those show commands. So a very nice show command is show EVPN instance. I like this because it is just giving an overview into that EVI, that EVPN virtual instance. A very handy show command for you to validate EVPN. And what you can see in this show EVPN instance is that we just have this one instance. Now you can have multiple EVIs, multiple virtual routing and forwarding instances, each containing their own EVI instance, of course. But because I didn't do that in the setup, they've all just gone into this default EVPN instance. That's what you're seeing here. So just note for future that you can have multiple EVIs, multiple EVPN setups on the same multi-layer switch, on the same router, but they're all should be operating in their own independent and separate VRFs, and then you could do route leaking, etc. between them. But what you can actually see here is the total number of interfaces that are participating in this EVI, and the up here is signifying that of the 2 that are participating, 2 of them are actually up. We can also see the number of interfaces, the IRB interfaces that are participating in this EVI. So 2, and 2 of these are up. Now for the neighbors, this is the neighbors that we have adjacency built to. So the first one, 0, being the default EVPN, but we have 2 neighbors in the default switch table, that is to leaf 2 and to leaf 3 from, again, leaf 1's perspective. And we also have the multi-hop ESIs, the Ethernet segment identifiers. So there's been 2, which has been automatically configured, automatically generated by leaf 2 and leaf 3, just so you're aware, because you can actually see that each of these hosts are, guess what, they're single homed. There's no multi-hopped tenancy here. It's all single hopped tenancy, single home, sorry, tenancy. So the leaves are automatically generating an all 0 10 hex value to really indicate over to leaf 1 from leaf 2 and leaf 3 that these are single homed devices, because it's all 0. And here at the end, we could see the amount of MAC addresses that have been learned both locally and remote. So I like that command. It's a very good command just to initially show, is the EVI instance actually up, running? Are your interfaces up? Do you have the right amount of interfaces participating in that EVI? And a little bit more. But of course, it doesn't give enough granular information. And just get a little bit of space. Another command that I really like for validating EVPN is show EVPN database. Now look at this. Let me expand this a little bit more. So it's hogged over leaf 3's part of the display, but that's fine. We can run with that. Everything's from leaf 1's perspective anyway. But here you can actually see in the EVPN database the VLAN. Now this isn't actually referring to the VLAN, to that layer 2 VLAN, because you can note here that there's no VLAN 10, there's no VLAN 20 actually shown here. It's actually referring to the domain, so that we know by configuration that VLAN 10 is being referenced and mapped to VNI 5010, and VLAN 20 is being referenced or mapped and aligned to VNI 5020. And that information is shown here because we've got our VNIs for 5020 and our VNIs for 5010. So when you see VLAN up here, it's not really referring to the VLAN, it is referring to that VxLAN virtual network identifier, that VNI. But here you can see all of the MAC addresses that have been learned. And this is all learned via that route type 2, which is that bread and butter. It's the foundation of EVPN. Route type 2 advertises a MAC address. It advertises also the Ethernet segment identifier, the ESI, that MAC address is sitting behind, and maybe an IP address along with route distinguisher, route target, maybe some form of our communities as well. So we've got all our MAC addresses here, and you can actually see where were these actually learned from. So what is the active source? So we can actually see for this MAC address, whoever that is, that has been learned from the router, that neighbor with the loopback 0 address 1.1.1.4, which is leaf 2. So we know that this MAC address here is sitting behind leaf 2. We can then see when was it actually learned and what is the IP address. So 192.168.10.12, that is this host here. So this host here has this MAC address. How cool is that? Leaf 1 has just learned remotely from leaf 2 that you have this MAC address with this IP address. I don't know about you, but I think that's really cool. There's obviously some pieces of the puzzle missing here, such as what's my egress interface to actually get there. We'll come on to that, but this is just the database itself. Well, let's actually try this. Just do show EVPN database. Just hit question mark, and I want to look at the MAC address, and let's focus in on the same MAC address. I'm just going to copy this so I don't get any errors and paste it. And do we have detail? We don't have detail. Do we have extensive? So now we can see the timeline. We can see actually quite a bit more information into this MAC address. So now you can actually see what is the VNI for, well, you could see it before, but it's a bit more in a nicer view. It's not so condensed. But this MAC address is sitting behind VNI 5010. This is coming from the source. We know that's leaf 2, and it is currently active. We can also see the IP address of that MAC address, that host, i.e. host 2. But here's all the events. This is very handy for troubleshooters, so you can see all the events. So if this up here was inactive, you could actually use this to see, okay, well, what's happened with this host, and maybe get an idea. Again, this isn't a troubleshooting video, but get an idea of what's happened to host 2 on this network. And let's actually compare this show EVPN database. Let me just hit up once. Let's actually compare this to the show ARP table. Now there's of course some similarities here. So when we look at the show ARP, leaf 1 has learned the IP address for all of these MAC addresses. So if we look at host 1, where it's got this IP address of 192.168.10.11, which is right about here, we can now see the MAC address of this. We can also see what is the name of that particular host and what is the interface to get to that particular device. So we need to go out of the IRB.10 interface and out of the GIGI 000 interface as well. And flags, you know, this has been learnt permanently, and it's remote to that leaf device. Now if we compare this to the show EVPN database, so we got 192.168.10.11 here, we could see the timestamp for this when it was actually learned. We could see the egress interface, we could see the MAC address here, but the addition here is we've got the VNI. So we know just by using the show EVPN database and the show ARP, we could see the MAC address, we could see the IP address, you could see the timestamp, but additionally you can see the VNI. So for me, the show EVPN database is really a glorified show ARP table of all local learned tenants. But additionally, in the show EVPN database, you then have all of the remote learned MAC addresses as well, because it's just a show EVPN database. So really, we've just confirmed that EVPN is functioning, because we can see in the EVPN database just here that we have got the locally, let me expand this more. We have got the locally and remote learned IP addresses. So you can actually see here again 192.168.20.13. That is host 3 here. That is in VNI 5020. That is absolutely correct. So we know the EVPN database is running, and we compare that to a show ARP. For me, the EVPN database just adds more context, but around EVPN. But let's actually see, how can you confirm the VxLAN? Well, a good command just to initially confirm the interfaces for VxLAN is to do show interfaces VxLAN, or so it's actually VTEP. And if I hit question mark, I just want to have a brief description. So now we can actually see that the VTEP itself is enabled and the physical link is up. Whether it be these two interfaces here, it doesn't matter, because this is just a physical interface. But then we've got our logical interfaces itself. So we've got this VTEP here, we've got this VTEP here, and we've got this VTEP here. Now we actually didn't build that in the configuration. The command line interface, Junos in this perspective, and any vendor will automatically, or should automatically, build those VTEP tunnels when they start to participate in a particular routing function. So we encapsulated EVPN into VxLAN, and when a remote device starts to receive EVPNs and is configured to receive EVPNs, it will just automatically build these VTEP tunnels. But you can also see for this particular VTEP tunnel that we have got this ESI. Again, this is a single homed device, as you can see here. This is actually referring to the VTEP tunnel to get to host 1. But there's other commands you could actually do. So you could do show interfaces VTEP terse. And now we're going to get an even more condensed view. So we could see those 3 VTEP tunnels which I just described. This is to our local host, and we've now got 2 remote or 2 tunnels to get to this VTEP, to this VTEP, and both of these are up. But you can also, let's just compare this to show interfaces VTEP extensive. Now we're going to get a lot more output. Just look at all of this. So here's the previous command here. We could see the VTEP tunnel link is up, the MTU is unlimited, the speed is unlimited. We're using VxLAN tunnel endpoints as encapsulation. Of course, we obviously know that. There's been no hold times up or down. We can also see the amount of input and output bytes. But this is for the physical interface for that particular VTEP. However, if we scroll down, we've then got the logical interface for this VTEP tunnel. We could see the ESI again being single homed. We could see the VxLAN tunnel endpoint 1.1.1.3, which is leaf 1. We know it's going to the layer 2 routing instance into this default switch, and the layer 3 routing instance is also going into default because we've not configured any particular VRFs. And now we can see as well the amount of input and output bytes and statistics and transit statistics for this particular VTEP and all the other VTEPs. So note here, the VxLAN tunnel endpoint address 1.1.1.5, that is leaf 3. And we can see it's going to the default layer 2 instance and to the default layer 3 instance, etc, etc. So this is a very good command to confirm your VxLAN VTEPs are up, functioning, transmitting, receiving, and have they had any errors or problems, etc, etc, during this configuration or after this configuration. A nice little command you can also do. It's not very complicated, but it's still very handy. Show VLANs. And this is really handy because what you could see is from host 1's perspective, it's only got VLAN 10, but I had to configure it for VLAN 20 as well because I wanted it to participate not only in the VNI for 5010, but also in the VNI for 5020. As I was saying at the beginning, this needs to be configured, and we need to we're verifying here, are we going to have inter-VNI connectivity? So we've got our default VLAN here, and you can see that there's nothing configured there. That's fine, don't really care about that. But here we've got VLAN 10 and VLAN 20 with this particular tag ID. And note, you can now see what's the egress interface to get to VLAN 10. So we're saying here, or Junos is saying here for VLAN 10, you can get out of this interface. But also, we have got devices, interested devices remotely in VLAN 10. And to get to there, you've got to go through these VTEP tunnels. And we just confirmed what the status is for those VTEP tunnels. And the same for VLAN 20. To get to those remote interested devices, we've got to go through these VXLAN VTEP tunnels, these destinations to get to those interested devices. So it's a very good handy show command that to verify, do your VLANs, your locally configured VLANs, have connectivity through a VTEP tunnel? But what if you wanted to confirm, well, is VLAN 20 or VLAN 10 being mapped to a particular VNI? Here's a command, show Ethernet switching VXLAN tunnel endpoint, and I want to do this for the source. Note now, it's saying for this source VTEP 1.1.1.3, which is leaf 1, for this interface, which is we're using to build our adjacencies and the tunnel endpoints, etc., the tunneling, we're using the loopback 0. The layer 2, I always think that stands for round trip time, but it's not. It's the routing table. I've always got to remember that. The layer 2 routing table is the default switch for both of these bridge domains, VLAN 10, VLAN 20. So here's the name, VLAN 10, VLAN 20, and here's the ID for each one of those names. So tag 10, tag 20 for VLAN 10, VLAN 20 respectively. And they are associated to VNI 5010 and to VNI 5020. So right then and there, you can confirm using this one simple command, are your VLANs mapped, aligned, configured to the right VXLAN VNI. You can also do the same for the remote device. So you could do show Ethernet switching VXLAN tunnel endpoint remote. And it's a bit of a compact show command this, but it is still handy nonetheless. Here you can see the remote VTEP 1.1.1.4, 1.1.1.5, that is leaf 2 and leaf 3 respectively, who have built tunnels to this source VTEP, that is leaf 3. and we can see what VNIs they are actually advertising, or are they interested in participating in. So VNI 5010, 5020, and the same here for leaf 3. And here we're actually saying to get to leaf 2 or to get to leaf 3, to get to these VNIs, you've got to go through this VTEP tunnel. To get to leaf 3, to get to these VNIs 5010 and 5020, you've got to go through this VTEP tunnel here. And we've already confirmed using that show interfaces VTEP brief, terse, extensive, that those VTEP tunnels, those logical tunnels, those VTEP devices, those logical devices are up, functioning, and are actually passing traffic. So step by step here, we're actually confirming the underlay is working, the overlay is working, we have reachability, EVPN is exchanging all the MAC and IP addresses. We've compared that to the show ARP table. We've confirmed the VxLAN tunnel endpoints where the encapsulation and de-encapsulation take place, that they've got the tunnels built, and now we've just confirmed that the VLANs are mapped to a particular VNI, and to get to those VNIs on remotely learned, remotely interested devices, we've got to go through, we need to communicate to these remote VTEP tunnels, and again those are up. So what is another command that you can use to validate that EVPN and VxLAN is configured and set up correctly and transferring routes? And full disclosure, you can probably see my color of my top has changed. I have been to the gym. I don't do these videos all at once. I've been to the gym. Needless to say, I need a new top. Say no more. But back on the topic, what is another command that you can use to validate EVPN? Well, this is a command that you should be aware of, and that is show Ethernet switching, and let's do table. I absolutely like this command because, let me just do a little bit more and maximize it. And there we go, I've maximized it now. I like this command, show Ethernet switching table, because it's showing, of course, all the entries that are in our Ethernet switching table. So we've got our ARP table, which is the MAC address and the IP address. We've got our EVPN database, which is all local and remote learned MAC addresses that have been learned via EVPN and the different route types. We've got the VxLAN interfaces, and we've got the remote and source VTEPs and all those tables. So it's a lot of information, I know, but I do like this because it's just standard, bog standard. This is bread and butter switching. And what we have here is, again, all of these MAC addresses, whatever they may be, and you can obviously see there's no IP address referring to these MAC addresses. We would need the ARP table for that. That's why I showed that. But we can actually see all of the MAC addresses that have been learned, obviously remotely, and installed into the layer 2 Ethernet switching table on leaf 1. And we can see that all of these MAC addresses here are associated to VLAN 10. And all of these MAC addresses here are associated to VLAN 20. But what we can also see is how they've been learned. So we can actually see for this entry just here, this is dynamically learned. So that would actually indicate that this MAC address right about here, because it's the only one that's been dynamically learned, is probably host 1's MAC address. But then we've got this DR here. So what does DR mean? So DR, if you look at the flags, means it's been dynamically learned. It's a dynamically learned MAC address. And R means remote. So that means that this particular MAC address here, as I highlighted, has been learned dynamically, but remotely. It's not local to leaf 1. And how has that been learned? Via EVPN. But we can also see what is the interface to get to. That's the host one. So yeah, I was right, because we could see GigE000, which is this interface here. But if we just pick on, say, this entry, and I've just tidied it up a little bit. So let's just pick on this entry just here. So this MAC address, which is pointing towards this VTEP tunnel. So that is VTEP tunnel 32770. So what we could then do is go back into our show interfaces VTEP and even into our show Ethernet switching VxLAN tunnel source, or ideally remote, to see, well, where's this MAC address actually being advertised from? But we can actually see here that it's been advertised from this particular router ID, this IP address, because they're the same really in this setup, 1.1.1.5. That is, and it's hidden, but that is leaf 3's router ID. That is leaf 3's loopback 0 address. It's a very handy command. And I've maximized the screen now because I'm going to go into the routing table, and there's going to be lots of information. We don't really need to see the background, the EVPN setup. I just like to have it there as a point of reference. But let's now see the routing table. So let me get a little bit of space, and I'm just going to do show route. And you can see right at the top, we've got our inet.0. So this is basically the IPv4 default routing table. And we've got our /32s for spine 1, for spine 2, for leaf 2, for leaf, sorry, that is spine 1, spine 2, that is ourselves, leaf 1, leaf 2 and leaf 3. Note there's two different ways to get to leaf 2 and leaf 3 because we set up the underlay to have two adjacencies to spine 1 and spine 2. And then we've got the all the addressing on interfaces that's connecting the underlay. You can see there's a lot of OSPF and some EVPN. So note here 192.168.10.11/32 that has been learned via EVPN. That, if I remember correctly, is host 1's IP address via IRB.10. So all the entries that you would expect, but if I keep hitting more, we suddenly have this bgp.evpn.0, and look at all the entries. I mean, it's absolutely astonishing. Look at all the entries just in that one routing table. That's why I maximize this. And as you scroll further down, you've then got this default switch .evpn.0. And again, some entries in there, and a lot of entries in there, and then a underscore default underscore EVPN table. So needless to say, that's a lot. But why do we have all these different EVPN tables? Well, let's look at the process. So let's say we've got packets coming into a particular interface. So I'm just going to call this the ingress interface here. And they're coming in, they get queued, etc., etc. But in the world of BGP, and don't forget EVPN is a family member of BGP, is those packets which have been received will first go to what's called a rib-in, I've ran out of space, but a rib-in table. So those packets will go through and go past a particular policy, a policy statement. And that allows the user, the administrator, whoever's got control of this network, to define what routes that have come through the ingress interface into the rib-in, that BGP routing information base in table, to decide what routes to accept. Because after this, what happens is it's then passed into that inet.0 routing table. So that is basically the default master routing table. But what about these other tables? And if you're wondering what the name of this table is, well, we've actually just seen it. And let me scroll back up. This is actually the show route table, BGP. And actually, let me hit question mark. This right here, bgp.evpn.0, this is that rib-in. So I'm just going to copy it here. So the bgp.evpn.0, that is the rib-in table. And on the command line interface, if I just enter that in, and let's tab it out, here is all the routes that have been received remotely, but also locally, via BGP using EVPN as signaling. This is the rib-in table. This is before any policy statements come into effect. This is all those BGP LAN routes via EVPN for IPv4. inet 0 basically, and there's 44 destinations, 74 routes, 44 which are active, and then you could see all of the routes here. Now before I go any further, let's actually just describe the makeup of what you're seeing here. So let's actually just now focus in on this particular entry just here. Now I'm going to try and write that out because it is quite long. So first, this one right at the beginning, what does that actually signify? What this signifies is what is that route type. So here it's actually indicating, referencing that this is a route type 1. And there's two different types of route type 1. So you've got a route type 1 for auto discovery for the ESI, and then you've got route type 1 for aliasing for the EVPN virtual instance for the EVI. So, but in general, it's a 1, and you can actually see just down here, it's referencing 2. So that would be for all the MAC addresses which have been learned, and maybe the IP addresses. That is the root type 2 function to advertise a MAC address, maybe an IP address, and the Ethernet segment identifier, and all the other contents that go into that root type 2. But needless to say, that first part identifies what is that root type. Is it root type 1, 2, 3, 4, 5, or maybe even higher? And then we've got this next part here, going from here to there. So I'm just going to try and draw that out. So that's 1.1.1.4. What is this? This is the router ID. So that's 1.1.1.4. Or in this case, it could be the loopback 0. It's hard to know which way. They're both the same. But that is who's advertising it. So it's 1.1.1.4. So we know that this is coming from leaf 2. But then we've got this double semicolon. And then we've got, I'm not going to write it all out, but then we've got this huge value just here. This is then the Ethernet segment identifier, the ESI. And we could also then see just here, right at the end, is this then followed by colons FFFF colon FF colon F. It's not even a colon there. It gets very confusing, but that is basically indicating that this is a root type 1 for the EVI. And what we can see is that leaf 2 is advertising this root type 1, and it's basically saying, and you can actually see it's been reflected from spine 1 here, because that is spine 1's loopback address. It's saying that if you want to get to this ESI value, which is all these numbers here, I'm not going to write it out, you could get to it via this way, and you could get to it via this way. So very, very handy information. But let's get another one. So now let's look at this root type 2. So what we've got here is the 2. So this is indicating that it is a root type 2. And then we've got our colon, and again, then we've got 1.1, and let's look at this one here, 1.1.1.4 colon 65.100. What is this? This is that root distinguisher that has been configured. We've got this first part here I've set up to be the router ID, of course, so we know that's coming from leaf 2. And then we've got this ASN number here. All of this makes up the root distinguisher. But then we've got a double colon with 5010. What is this? This is the virtual network instance. So this MAC address, which then follows, and I'm not going to write it all out, but we've got double colon, and I'm just going to do MAC address, which would be this MAC address here, is saying that if you want to get to this MAC address, this layer 2 information for VNI, this has been advertised by this root distinguisher. And if you want to get to it, you could do so via this way, and you could do so via this way, via spine 1 and via spine 2. So lots of information there. And if I keep going, you can see all the different root type 2s. And actually note here is an IP address. So this is actually the IRB gateway for the VNI 5010. And this is coming from leaf 2. So this is actually the IP address and the MAC address of the IRB.10 interface on leaf 2. And you can get to this particular IP address, which is configured to be within this MAC address, via this route here or via this route here. So a lot of information. If you keep going, you can then go into the ingress multicast. So that is for BUM traffic, broadcast, unknown unicast, and multicast traffic. So this is EVPN route type 3 coming from leaf 2 again, or from leaf 1. So this is the route distinguisher for leaf 1. This is the route distinguisher for leaf 2. This is for VNI 5020. This is for VNI 5010. And here we've then got the advertising router as well. So that is again, of course, leaf 2, and down here leaf 4. But this is for ingress replication. This is the IM message. I forget what it's called, to be honest, but this is for route type 3. So lots of information, but please recall that this is just the rib in table. So all those packets that have come into that ingress interface then get passed, because this is BGP at the end of the day, get passed to a rib in table. And that in the Junos world is your BGP.EVPN.0 table. That is basically what we've just looked at. But what about these other tables? We've got an underscore default underscore EVPN.0 table, and also we've got a default.switch.EVPN.0 table. So any routes which pass a particular policy, don't forget we apply a policy statement in this ribbon. Any prefixes that have been learned and pass these policy statements that will then get passed to one or maybe both of these tables. What is the difference? The difference is that this table here is where you will find your route type 4. Route type 4 is all about that designated forwarder when you've got a multi-homed tenant. So we've only got single-homed tenants in this setup, so you're not going to see any route type 4s because it's single-homed. You only have a designated forwarder or DF when there's a multi-home tenant, when a server or whatever it may be has two connections to the upstream, to leaf 1, leaf 2, just for example. What you could also see in here though is the route type 1s as well, and that's important because with the route type 4 it has to reference the ESIs that's contained in that route type 1, because this multi-homed tenant is going to be sitting behind an ESI which is identified in the route type 1, and that route type 4 identifies for bum traffic who's going to be dropping packets and who's going to be forwarding bum traffic, but where does that host sit behind, i.e. what is that Ethernet segment identified? Guess what? That's identified in route type 1. So yes, very complicated. As I said, EVPN is a big complicated protocol, but really the default.EVPN.0 table, or I should say the underscore table, is where you'll find your route type 4 and your route type 1. But what about this default.switch.EVPN.0 table? This is where you will find your route type 1, you will find it in there as well, your route type 2 and your route type 3. So this allows you to see all the entries that have passed that policy statement, that have been sent through that policy statement after going through the ribbon table and have then been passed to one of these two tables. So let's put that into practice. So let's do show route table, and I'm just going to hit question mark. So let's do this table. Actually no, let's do the default-switch.evpn.0. Again, in this table you will see your route type 1s, your route type 2s and your route type 3s that have passed through that rib in table, i.e. that initial BGP.EVPN0. This is the BGP rib in table for EVPN. But let's just do default switch, and to be honest, you are going to see pretty much everything that I just showed on that rib in table, because there's no policy statements actually defined, configured for this setup. It's an easy lab, why make it complicated? But here you can see the route type 1s. Again, how do I know that? Because you can see 1 here, 1, and then you can see a 2 here. And if I keep going, at some point we are going to see, there you go, the route type 3s. And I've just remembered what IM stands for, ingress multicast, I think it stands for. I'm really going to have to check that. But again, the information is what it is. Now, one command that I do like to actually show and go through to help validate EVPN is show route. If I spell it right, it always helps. I'm going to do it for the table. I'm going to do it for the same table, but then I want to match on a particular prefix. Now, let's say, for example, I want to match on all EVPN route type 2s, which advertise that MAC address. What you could do is open the bracket 2, (**, close, detail. What this is basically saying is I want to look into the contents of this default switch EVPN.0 table, and I want to match on all EVPN route type 2s, but I don't really care, hence the wildcard, the asterisk, I don't really care what the route distinguisher is and the MAC address is. I don't care, but I do want to see the detail behind it. So if I hit detail, you're then going to get, whoa, suddenly a lot more information. And this is great because this is where the glorious world of BGP really starts to shine through. So what you can see here for this particular route type 2, which is coming from, let's actually not do this one, it's from ourselves. So let me just hit space a few times and let's get to another one. There we go. So I'm going to pick on this guy here. So here we go. This route type 2, which is coming from 1.1.1.4:65100, that is the route distinguisher for leaf 2. What we can now see is all those PAs or path attributes that you get with BGP. When we use BGP, we are advertising network layer reachability information, i.e. the prefix. And those path attributes really allow the world of BGP, whether it be IGP or eBGP, depending on the attribute, to steer traffic, to manipulate it. And there are different types of path attributes. So next hop is a path attribute. We can see our route distinguisher up here as well. We can see the preference 170, so that is the EVPN preference. We could see what source is it coming from. We could see how am I going to get to this particular MAC address, which is up here. How am I going to get to it? So the next hop is actually 1.1.1.4, which is leaf 2, and I could get to that via spine 1 or spine 2, as we actually know. But I can also see what is my local autonomous system and what is the peer autonomous system. So we could see 65100 here and 65100 here. That implies that we are using IBGP, of course. We can also see the age. We could see the metric. We could see the AS path. That is a well-known and mandatory path attribute. And then we've got our community tags as well and cluster lists. Because we're using route reflectors, we've got the cluster list here as well. We've got the Ethernet segment identifier. Note it's been automatically generated for me. I could see what's the router ID. So this is coming from spine 1. And a lot more. So you can really see there that BGP adds a lot of context to EVPN. EVPN is a sub-protocol. It's a family member of BGP. And because of that, you get all of these amazing path attributes when you start to enter in that command like detail at the end. But the problem here is that it's showing me, you could see it's only at 22%, and I'm having to hit space a lot. You know, there's a lot of entries here for this default switching EVPN.0 table, and that's to be expected because if I hit up, I said I just want to see all route type 2s, but I don't really care what the MAC address and IP address and the route distinguisher is. I just want to see everything and the detail behind it. So what you can do, and what I would recommend, is if you want to filter on a particular index, if you do brief, then what you can do is just identify that particular route distinguisher, that advertising leaf or spine, depending on your setup, that is advertising those MAC addresses in this case, and just copy it. Absolutely just copy it from start all the way to the finish until you get to that slash. So I'm just going to hit copy it on that. Hopefully that works. Let me hit space a few times. And now if I hit back and paste that in, I did get it. And now do detail again. It's only now going to show me, you can see how much quicker that was, the contents of the learned prefix, which I just defined here. So the route type 2 coming from leaf 4 with this route distinguisher for VNI 5010 for this MAC address. I can see all the contents, the detail of this and the path attributes therein. It's a lot better way to get to that nitty gritty information, but a very helpful command there for you to see. But what about that other routing table for EVPN? So let's do show route table, question mark, and it was underscore default. It's 2 underscores actually, don't be caught off by that. There's 2 underscores there, it's a little bit hidden. It wasn't working. If you do 1 underscore, it won't auto-populate it for you. But now if I just do show route table, double underscore default, and hit enter, a lot smaller because again, This routing table for EVPN will store the root type 1s and the root type 4s. We don't have any designated folders. We don't have any root type 4s in this network. If you did, and they passed through that ribbon table after the policy check-in, they would be shown here. So that is how you can validate those three different routing tables. So again, that BGP, this BGP EVPN.0 is that rib-in table. That is for all received routes that are coming on the ingress interface before a policy statement has taken effect. The default switch EVPN.0, this is for your root type 1s, 2s and 3s after a policy statement has taken effect. And this double underscore default underscore EVPN, etc., this is for your root type 1s, your root type 4s, i.e. for multi-homed tenants after a policy statement has taken effect. But what is also another way to verify your inter-VNI connectivity is to do a ping test, of course. So if I just go into host 1, and let's say I want to ping from host 1 over to host 3, from 192.168.10.11 to 192.168.20.13. So ping 192.168.20.13. This will test the inter-VNI connectivity. And there we go. We've got inter-VNI connectivity from leaf 1 to leaf 3, from VLAN 10 to VLAN 20, from VNI 5010 into VNI 5020. And using those various show commands will allow you to verify your setup is correct, that VLANs are mapped accordingly, the IRB interface is the EVPN. So those are my top picks for validating EVPN. And so there we go, everybody. That is the end of this video. That is the end of this part into how to validate your EVPN VxLAN network. And to be honest, you can actually see there was a lot more commands that really focused on the EVPN side. And it's not because it's just biased that way. It's because VxLAN is just a tunneling protocol. It's a data plane tunneling protocol. It will set up a tunnel from a source VTEP to a remote VTEP and then send that data plane technology or packets through that tunnel. But it will also advertise those EVPN route types through that tunnel as well, which is why in the setup we define the encapsulation in EVPN to use VxLAN. But EVPN, there was a lot more show commands, wasn't there? We had the show EVPN instance, we had the show EVPN database, we had the show Ethernet switching for the VxLAN source and remote. I know that's the VxLAN, but we also had the show route tables for the BGP.EVPN.0 and for the show route table default switch EVPN.0 and the other table as well. And of course, other backup show commands such as show ARP, show VLANs. All of that you use together to validate your EVPN and VxLAN setup to ensure MAC addresses are being learned and to ensure that you have inter-VNI or maybe intra-VNI connectivity. So I hope you found that useful. Hope you found that informative. If you like my content, if you like this video, please give me a thumbs up. It's the best way to support my channel. Any questions or comments, let me know down in the comments box. I love hearing from you guys. Other than that, thanks for watching and goodbye.